Hello everyone, and welcome to your first screencasts of hopefully many this year, as it will help us save time in class and give us an opportunity to do more activities in class instead of just sitting there taking notes all day. These first two sections, you do not have any homework assigned with them, but it is information that you should know, and I'll expect you to know essentially. So real numbers, we've got counting numbers, whole numbers, integers, both positive and negative, rational numbers and irrational numbers. These are all considered real numbers. So let's take a look at what these are. So our counting numbers, well, when we count, we usually count 1, 2, 3, 4, etc. You may also see counting numbers be called natural numbers. Those can be used interchangeably. We also have whole numbers, and whole numbers are all of our natural counting numbers plus 0. Then we've got our integers. These are what I like to think of as the normal spots on our number line. So on a number line, you would typically have things like -3, -2, -1, 0, 1, 2, 3, etc. in both directions. So those are our integers. Next up, we've got our rational numbers, and these are all fractions that can be fractions and any kind of number that we can put in the form a over b. So like the number 2 can be put in the form 2 over 1, so that would be a rational number. Anything that we can put into a fraction. Irrational numbers are numbers that, well, you can't put them in a fraction. Good examples: non-perfect squares, the square root of 3, not a perfect square, not rational. And reals, all of our rationals and irrationals together. So this is kind of a branch, with counting numbers being the most specific up to rational. Irrational is kind of its own beast of sorts, and then we've got real numbers, which encompasses all of those. Can you place each number on the correct location on the real number line? So we've got these numbers here: -5, 12, square root of 7, -2/3, square root of 49, and -5 halves. So these are all in different categories, but we do want to put them on the number line. That's what we can do with real numbers. So let me pause for a second and draw a number line, and you should do the same. So now that I've got my number line, and hopefully you have yours, I'm going to assign letters to these numbers so it's a little bit easier and cleaner on the number line here. So let's call -5a, 12b, and we got c, d, e, and f. So -5, well, I see where -5 is in the number line, so I'll cross that out. 12, I also see that, so that's going to go right there. Now, square root of 7. I know that square root of 7, well, let's think. It's going to be between the square root of 4 and the square root of 9. Those are our perfect squares in between there. So the square root of 7 has to be between square root of 4 is 2, square root of 9 is 3, so square root of 7's got to be somewhere in here, a little bit closer to the 3. So there's our C. -2/3. -2/3 I know is going to be on the negative side and almost -1, so there we've got D. E, square root of 49, we know that is 7. And F, -5 halves, that's -2.5. So that's also going to be, it's going to be actually right before C. So I'll just kind of throw that in there. So there we've got our numbers on the number line. Properties for real numbers. Closure for addition and multiplication pretty much just means if you add real numbers, you'll get a real number in the end. If you multiply real numbers, you'll get a real number in the end. Commutative property, that's where we can move, 1 plus 2 is the same thing as 2 plus 1, or 3 times 2 is the same thing as 2 times 3. So commutative, we can think of commuting. Associative property is the one that deals with the parentheses, the one that deals with, how we group things. So we can have a plus b grouped, and then b plus c grouped. Identity for addition and multiplication. identity property for addition is going to be 0. Essentially what the identity property is what can you do to the number to keep it the same. So with addition we add 0. With multiplication we multiply by 1. Inverse is when you add or multiply by a version of the number in order to get back to the identity. So the inverse for addition, say we had x, the inverse is going to be negative x. Multiplication, if we have x, we're going to have 1 over x. Distributive of addition over multiplication, aka the distributive property, that pretty much just looks like your typical distributive property. And you guys know all these. The closure might be different for you, but for the most part, you've been seeing these for quite a while. Now here we're going to identify these properties. You can go ahead and pause. It might be a good idea so that way you can kind of practice on your own identifying, what property is this. But let's take a look at our first one. So we have 3 plus 8 times 5 equals 15 plus 40. Now it appears that, if we take 3 times 5, we get that 15, and then 8 times 5 gets us that 40. So though we're used to seeing distributive property with the number out in front, that appears to be exactly what's going on here. So this is going to be distributive. Let's take a look at our next one. 5 plus negative 5. Now 5 plus negative 5, that'll get us to 0. Negative 5 is a version of 5, so that's going to be our inverse property of addition. Okay, next one we have 1 times 6. Now when we do 1 times 6, we end up still with 6. So because the identity of that number has not changed, this is our identitive property of multiplication. Let's take a look at our next one. 6 plus 3 equals 3 plus 6. Now both statement that equation is true, and we've moved our numbers around, or they have commuted. So that's going to be our commutative property. And our last one, negative 10 plus 3 equals negative 7. So this is going to be an example of our closure. We added two numbers that were real, and we got a real number in the end. Unit analysis. You work 8 hours per week and earn $96. What's your earning rate? So we've got to find out how much we get per hour. So go ahead and pause and you can work this one out. But I'm going to go ahead. So it looks like we're going to take 96 divided by 8. And we know when we get that, we get, so this is hours. We have $12 per 1 hour, just by simplifying those. So there's our answer for that one. Next one. You travel 5.5 hours at 70 miles per hour. How far did you travel? So we know that if we're going 70 miles per hour, and if we went 5.5 hours, we're going to have to take 70 times 5.5, which gets us 385 miles. Let's take a look at the next one. You drive 60 miles per hour. What is your rate in feet per second? So let's set up our conversions just like you guys did back in chemistry. So we've got 60 miles for 1 hour. Now let's convert with the miles first. So I know that 1 mile is 5,280 feet. So we got down to feet. Now we got to change that hour to seconds. So we know 1 hour has 60 minutes, I don't know why that came up. And then 1 minute has 60 seconds. So let's make sure our units cross out where they should. So we got our miles to go away, hours to go away, and minutes. So now we're down to feet and seconds. And then we see there's 60 over here and 60 over there. So I'm just going to go ahead and cross them out. You don't have to. But when you multiply it all out and divide, we get 88 feet per second. Convert 125 miles to kilometers. So I've kind of already gone for you. 125 miles, and you, like you guys have already said, miles, and then we've got 1.61 kilometers per mile. Cross out our units, and we're left with 201.25 kilometers. Don't forget units, as it could cost you points. Algebraic expressions are different from numerical expressions because of the variables in there, and whenever we have a value for a variable, we plug that in and simplify. So here we have 4x squared plus 2 times x minus 4 minus 10, and x is negative 3. So first we're going to plug in our negative 3, then we'll simplify things, and so here we have 9, 4 times 9, 2 times negative 7 minus 10. So we end up 36 plus negative 14 minus 10, and we get 2 in the end. You are selling homemade cards at a local craft fair for $2.50 a card. You spend $85 for supplies. Write an algebraic expression to indicate your earnings. So earnings are money that you're going to get. So since you spent $85 for supplies, we're going to have, say, our P for profit be $2.50 per card minus our $85. Because this is how much we've earned, that's how much we spent at first. So how much money did you make if you sell 120 cards? So we use our same equation, 2.5, and we plug in 120 for the number of cards. And when we take 2.5 times 120 and subtract 85, we end up with 215. And that's the end of this screencast. Hopefully that was too bad. Again, there is no homework covering these sections, but just kind of, refresh your memory on some things. So until next time, thanks for watching.